Welcome again to another episode of What's the Word, an electrical industry podcast. Our guest today is Andrew Bleackley. He's the electrical coordinator at Wood PLC. Welcome to the show, Andrew.
Hi, thanks, Jason. Zach.
So today on the show, we're going to talk about QA, QC, quality assurance, quality control, and a whole bunch of other stuff probably associated with that. But before we do that today, can you tell us a little bit about yourself, Andrew?
Yeah, for sure. Got into the trade at about 2000. So it's been 23 and a half years for me. After doing my apprenticeship, finished off my journeyman's ticket in 2006. Taught with Jason, started the same day as Jay, way back in 2006. Instructed at SAIT for, I guess it was 7 years. If that was 10 years ago there, that picture behind you. So that was a while back. And after finishing off at SAIT, I got into quality control, kind of bounced around a little bit, got into doing more quality assurance, quality control, moved up to Saskatchewan industrial quality manager for a while before the company shut down. From there, I got into commissioning. So I've been all over Saskatchewan and now out in Ontario, most recently as an electrical construction coordinator with Wood. And the site that I'm on at the moment is a gold production facility called Cote Gold. And that's out in a place called Gogama, if you're familiar with where Timmins, Ontario is. It's about halfway between Timmins and Sudbury.
And so just even before we get into today's episode, so is this plant going to take the ore and then separate the product from it, or is it an actual mining facility?
It's a combination, right? So they do open pit mining, blast mining there on site. So they've been doing that for quite a while as part of blast prep and stockpiling. And then what we're building at the moment is the crushing dry facility and then into the wet production facility. So the idea being you start off with a rock that has some low grade ore and you end up with a gold bar at the end.
Oh, wow. Very cool.
This is one of those things like everyone thinks they know a bit about, but I'm sure we're going to find out in the next, 45 minutes that we know nothing about. So the three words or terms that we've thrown around, right? QA, quality assurance, QC, quality control, and commissioning. I don't know. From my days in the field, those all were pretty much the same thing. Make it work, make it look good, test it. Can you break them down? QA, QC, commissioning, what are the separation between those three?
Yeah, absolutely. So quality control starts down at your contractor level, at your worker level, right? So that is making sure that your installation is compliant with both Canadian Electrical Code project specs, as well as an inspection and test plan, your company's project quality plan, that kind of thing. Basically making sure that it's built right. Quality assurance, on the other hand, is run by your construction management group, your general contractor, client in some cases. And their job is to make sure that the QC is conformant with your project specs. And it's a second set of eyes on a second set of eyes, basically.
Almost like they're just making sure they're getting what they pay for, right? They release the specs.
Absolutely.
QA would be the third party. Well, I guess not even third party, but coming to make sure they're getting what they pay for when you guys sign the contract.
Absolutely, right, and that's entirely their job. Commissioning, you break down between kind of pre-commissioning and actual commissioning. So your pre-com is your basic energized conformity tests, right? Are your motors working the right direction? Are your loops complete for your control systems? Do your lights work? Are your plugs wired correctly, right? So that's kind of your pre-com, as compared to a commissioning, which has multiple steps, running up from basic run-in tests, say on a motor and a pump, all the way up to full process facility testing through complex systems and integration of systems between your PLCs, your devices out in the field, your equipment, right? And it's all done in stages.
And so when we're talking about stages, what sort of timeline are we looking at for, like, let's just talk about quality assurance first. That whole quality assurance process, does that take a long time to set up?
The quality assurance process, depending on who you're working for and who's running the job, typically those are already in place. With wood, for instance, there is a set inspection and test plan that all contractors conform to. Actually, it's a very good setup. Everybody uses the same inspection and test plan, which was different from how we used to do it back in the day, where each company had their own. You use standardized check sheets with them as well, so it breeds a real consistency, and it's actually something that's been developed over the courses of decades with this company from back when it was just an AMEC, or then again AMEC Foster Wheeler, and it's pulled itself through. So I mean, it's very proven in that respect. Other companies, you will submit your inspection plans and then they'll review them, right? So that's almost your first step within the entire process, is the submission of company check sheets, company inspection test plan, company quality plan for review by the quality assurance department to make sure that it's conforming with what they expect to see, as well as how that's going to work itself into project specifications.
When we're looking at the QA side of the project, is there a lot of coordination that's done by the general and the engineers to just make sure that each stage and section of the construction is done properly and that the right logistics are in place?
There is some. Typically speaking, your QA will be out during the process and doing audits, right? So between your construction coordinators and your quality assurance coordinators, they'll be doing frequent site visits out into the construction area. And what they're looking for is for conformity, right? As you're going through the process, are you doing what you said you were going to? Are you conforming with your inspection and test plan? So those are just general field audits that'll occur casually or formally throughout the entire length of a project, depending on what's within the overall project quality plan. Big thing where QA comes in is normally with the contractor. So the contractor themselves will do the quality control, and they'll go to the QA and say, okay, well, we're ready to do X activity, let's say a cable test. So they'll put in what's known as a witness and hold point, and the client QA will come out to witness that. So they'll watch them do a megger test or test the cable, or walk a cable tray with them to ensure that, yeah, you can actually move on with the next set of the process, or that the cable itself is conformant. From there, the paperwork goes in. So your paperwork at that point would go into the quality assurance department for their review and acceptance. And then that gets given back to your quality control in the contractor, who then basically puts it in a binder and gets it ready for turnover.
Paperwork would be critical. I mean, everything wants to be documented and recorded so the owner gets what they're getting, and that the installer or the contractor gets paid sooner and is doing it as efficiently and as quick as they can. Mm-hmm. One of the things that's coming up in industry over the last few years is the lack of material. So on a job site now, where we would have had the specifications in place to install product X, when that product can't be delivered now because of a lack of availability, does that then have to go back to the QA to tell the QC the change order, essentially?
Not really. Typically, where that'll go is through a request to engineering to have a specification deviation for an equivalent, right? So most specs are built with approved equivalent written right inside of the spec. The purpose to that is exactly what you're saying there. If there's an issue with supply, if there's an issue with, we don't want X device to hold the project up for the next 6 months and, completely shuttle the project, then we're going to have to come up with something. So what they'll do normally from a contractor is put that back to the engineering department and ask for that deviation. Now, a deviation, like if you're looking at a different brand of receptacle, right? So Leviton versus a TMB, something that's a hell of a lot easier to get through than a different size contactor or a different make and model of contractor. One of the reasons why you've got specs is to make sure that you've got consistency throughout multiple contractors, large contractors in a lot of cases, working on the same project sites, right? So when you're dealing with projects that are in the billions, you don't just have one electrical contractor, you've got six, right? And some of them are pretty massive. So when you've got that happening, when you're looking for those approved alternatives, it has to generally go through the client and owner, because that will impact and affect their maintenance going down the road, right? So normally you'd say, okay, well, we want an Eaton starter, right? We want general Eaton starters. And the reason you want that is so that the maintenance department can hold X number of starters in that same brand on the shelves. The minute you start introducing Schneider into the mix, well, now maintenance has to hold more supply, right? So like something like that is actually very relevant for permissions, and it's not taken lightly. And typically when you have an approved deviation across the site, it's kind of the first one to ask will set the tone for everybody else, because they got to it first, and now that information will be passed on from one contractor to the next to make sure you maintain that consistency throughout the entire job site, where it's like, yeah, well, X company couldn't find these. They had a 6-month lead time. I doubt you're going to be able to find them with anything less than 6-month lead time. We told them to use this. We'd like you to do the same.
Well, first of all, I want to just commend you on that answer or that reply, because we didn't talk about asking that question. So for you to come out and give us a really good answer there, I really appreciate that.
Oh, thank you.
Are these, so quality assurance, the customer, are they trained in the electrical industry? Are they looking for code violations and things like that? Or are they more looking for like, does this brand match the spec? Does this, is it matching the spec?
Short answer is all of the above.
Okay.
Right. So, and it really kind of comes back to where you are and what type of work you're doing. Right. And it's probably best to start with the idea of CEC. When it comes to Canadian electrical code in quality control and quality assurance programs, it's the minimum. It is the absolute minimum that has to be met. And sometimes it's not actually met. You've got in section 2, where you have the ability to override Canadian electrical code through manufacturer's recommendations, approved engineering drawings, right? There are times where the deviation will go in based on that section, right? It is there as a base minimum. So when you're working in, say, residential, your CEC will be your ruling document. 9 times out of 10, things like quality control programs and quality assurance programs have not made it to that part of the industry yet. Comparatively, seeing it more so in commercial and especially in industrial applications, mining, processing facilities, and stuff like that, your biggest overrider is your specification. And it goes for everything from cable tray is probably a really good example. So with cable tray, you've got the code, and the code says, yeah, you have to run cable tray like this, and you can only have so much space above it, and that kind of thing. And if you're going into this area, it has to be this type of material. Fantastic. With your quality assurance people, right, they are going to come in and they're going to look at something called NEMA VE2, and NEMA VE2 tells you how you support cable tray. And it's that'll work into it. Along with that, you're looking at tray fill and then derating, and that all goes together. And again, you can get away from certain things like derating if you have to, saying, yeah, the engineer has accounted for that, right? So it's completely accounted for. The inspector's not going to go and look at it. But I guess coming back to your question as well is the QA people themselves, right? So I know I kind of diverged a little bit, but the QA folks themselves are typically either trained electricians with years of experience, or they are engineers, or you'll see both, right, come into play. Sometimes you've got an engineer, sometimes you've got a tech, sometimes it's an electrician. Your team will typically be made up of a combination of all of those, just because each person's going to bring something a little bit different to that role. Sometimes your construction coordinators will go in and they'll do quality assurance, right? And they'll step in to help. I've done that quite a bit actually on this project, just because, timing or whatever the case is, or oh, that guy's got witness and hold over there. We don't want to hold the project up. Go and check it out, right? So again, everything comes into play, and your specs honestly build a lot more than your code, right? Your code, like I say, is it's a minimum. Your specifications for, do I need to use EMT versus rigid? Can I get away with tech cable? Things like that. That's really where you can build it to code 100 different ways, but you only have one way to build a project. And that's based on your prints. And that's where your specs come in.
That is a good point, because we do often look at the code as the rules, but yeah, there could be rules in place that are tighter or more stringent. And yeah, no, that's really interesting to know. Looking at the quality control, I've talked to many electricians over the years that work in industrial plants and facilities locally in northern Alberta. Can you kind of talk a little bit about the quality control? I'm kind of conflicted here. Who's doing the quality control? Is it the installing contractor, or is it a third party coming to verify the installation?
So your quality control is done by your installing contractor always. And the reason why that comes in, funny if you bring up Northern Alberta, McMurray specifically, and kind of go back to where a lot of this began. And it's the same thing with safety, right? So 30 years ago, 35, 40 years ago, even when we were all apprenticing and coming up through, and people ahead of us, safety wasn't really a big thing. It wasn't mandated. There was some basic idea behind it, and it was the Fort McMurray contractors and your Suncors and your Syncrudes that really pushed the safety, and they did so because of financial reasons. And it spread through the industry to the point now where you see that even out in a residential setting. Quality control and quality assurance came from the same place, right? So it was coming from systemic issues of product failure. It was coming from installation issues, lack of consistency, things like that. So what was put on the contractors to work in those production facilities and in those mining facilities was basically, how are you going to make sure that you are doing what you're supposed to do? How do we verify this? And this is where the first quality control plans came from. Like, copy and steal everything is the old one, right? And I know when I first started in, it didn't matter what company I was with, we all had the same check sheets. So when it came to quality control, the entire purpose there is in order to get paid, right, your installation contractor has to actually show that they are doing things to not only code, but also to project specifications, also to their own quality plan, be it a corporate one or project specific. And because you'll have those on every project as well as a project specific, because I mean, your overall corporate quality plans, 400 pages, right? You don't need that. And you may actually run into a case where you're doing work that's not covered by that. Additionally, then you get your quality assurance, and kind of where you were talking about there, that's your third party, your cold eyes, I suppose, right? Because I mean, you're coming in as a general contractor, engineering procurement group, EPCM group, and you're there representing the client. So your job, so quality control's job is, they want to ensure that their electricians or pipe fitters or whatever are doing their job properly. Quality assurance is making sure that the contractor is doing their job properly. So your QC is an internal check, your QA is your external check. And kind of on that side note, for anybody that might be listening, if you want to be the most hated person on site, go be the QC guy. I promise you that is probably the absolute most hated position on site. And more so than safety, because safety comes in and says, you're not doing that right. It's unsafe. You're not doing it right. And you get into a discussion with a safety officer about why this is right or acceptable or whatever the case is. Your quality control personnel, they know what your job is because they've done it. If you're working for the right contractor, they're coming out of the trenches, right? These are electricians. And it's like, I know what your job is and you did it wrong. Go fix it. And that's where you start to see the discussions happen between QC and QA as to what's actually worth it and what corners can be cut, or is there a bit of an easement that we can say, okay, well, in this case, this installation, yeah, we're going to leave it, but you don't do that again, or I will shut it down, right? Or this is just outright unacceptable for the following 10 reasons, right? And it sparks heated conversations, is probably the best way to put it, between both the contractor and your QA, and sometimes even internally between your construction coordinators and the QA department, and then people above the QA department as well. So it's definitely where you want to be onerous enough to ensure that you've got the right type of installation, and compared to not putting such a hamper and a restriction on a contractor that you basically make it non-profitable, right? The more technical, the higher level of the installation, the tighter the restrictions are going to be, and for what can slide or won't slide. But in general, yeah, that's kind of your differences right there.
You drew a parallel there between QA, QC, and safety, which I've been thinking, I don't know, this whole time. Like there's a big parallel between those two, right? We saw a need for something within the industry. We brought in some new procedures and policies. And of course, along with that, we all know has come a ton of paperwork. Hopefully that system's getting more streamlined, and we can probably talk about that in a couple minutes, but there's no way QA QC is going anywhere, right? It's here to stay. It's moving forward. How is it progressing, in the last 10 years that you've been doing it? What strides have they made moving forward, and where do you see it, I guess, in 10 more years?
In the last 10 years, where the biggest thing that hit me was when I needed to do a quality plan and actually build a commercial quality program almost out of nothing, for a mall. We were doing a project in Edmonton, and it was just a mall refurb. And they came back to us and they're like, okay, great. Well, we need to see your quality control stuff. And they're like, oh, well, that's only on the industrial side. Like, okay, well, that's great. But as a requirement of getting the job, you need to show us your commercial quality control, which was brand new. No one had done that for anything that I've ever been with. So basically sat down, cannibalized the industrial manual, and then created a new one for commercial that was a bit lighter than what our industrial standards were, because I mean the industrial standards are like here, right? And the commercial standards, well, they were still high. It was okay, well, what do we actually need to do? So like safety, you're starting to see it move down from the industrial into your commercial standpoint. And then eventually, it wouldn't shock me at all if some of the larger multifamily residential projects would start requiring it, and even down to your housing level.
Well,
That's
I would hope. I'd hope to a certain degree it's there residentially now, anyways, right? A builder, your big builders. I would hope they have somebody going to site while the construction's taking place and at least looking, right, with a little bit of knowledge. I mean, you hope, right? You hear horror stories, but I think it's a good thing, right? I think the important thing is to find that fine line between hampering the contractor's ability to make a profit and also doing what they're paid to do, right? Properly, to code, to spec, to law. So that's
absolutely. It's what's interesting is, I mean, even, and again, I'm not, it's been a long time since I've done housing, so I don't know if there is a lot of associated paperwork, whether or not. I imagine there's probably a bit more than there was back in the day. But even something as basic as doing a Megger check, or an installation resistance check to make sure that your tech cable is good, if you're feeding in a multifamily type of instance, or plug testing, right, which is something that we used to do. It's one of the things when you're doing finishing, right? You fire up the breakers, turn the power on. Great, all the lights work? Yep, they do. Okay, great. Take a plug tester, go around to every receptacle and make sure it's wired right. That's the basic QC. And it's something that was done on every job I ever did in housing, multifamily housing, and that kind of thing. We never recorded it, right? We just made sure that it worked. And that's kind of where I'm not sure if it's progressed into, okay, great, here's a basic check sheet. Did you do this? Yep. Did you do that? Yep. Right. That kind of thing.
I think that check sheet now is some app on a phone, and you take a picture of everything that you test along the way, and it all saves to a big file, right? To save some headaches down the road, hopefully. So,
mm-hmm.
And I imagine that's what it's like in industrial too, right? I'm sure technology's really changed the process and hopefully streamlined it. Could be
You
wrong.
would think, but no. We have tried. I have tried working in jobs where we've used iPads. I've tried working on projects where we've tried to do bigger things for quality, and it sometimes works. It sometimes doesn't. It generally doesn't stick, right? People don't like change. And everybody thinks that using the iPad or a field tablet or whatever is going to be the answer. And 9 times out of 10, it is still easier and more reliable to use paper. And it's incredible that it really hasn't moved beyond that. Now, commissioning has truly moved beyond that. We've got programs such as Hexagon, Smart Completions, things like that, where it's all organized within there. And that's probably where the technology is going right now, is to organize everything so it feeds into a common system to say, okay, great, all checks are done. But at the end of the day, you're walking around outside with a clipboard, with a binder, and you've got dirty pieces of paper that have got covered in blue ink. And in some respects, that's what everybody wants to see. And the reason that you want to see that from an owner's side is it's another piece of evidence that someone's actually done their job properly, that they didn't do their QC from the office and just pencil whip 1,000 documents. And oh yeah, great, look at that. It looks nice. It's all typed up. Isn't this wonderful? Did you ever actually go out in the field and do this? As compared to someone's handwriting with a half crumpled piece of paper, and it's obviously been exposed to the weather, right? And that's that fine line as well between making it neat as compared to actual practical application of that. And really, paper doesn't run out of batteries. Worst that's going to happen is you run out of ink, right? You haven't got to worry about a Wi-Fi connection. You can take a binder anywhere and you can do QC manually. And 9 times out of 10, that's exactly how it's done. It's even still in the big projects.
I've got on my notes here to exactly ask about that, because earlier you mentioned how the QC person, it would be the most hated person on site. And I remember being part of the installation on a skyscraper, and at the end of the job, right, we'd have to check in with the guy on QC all the time, and he was very nitpicky, and he had his clipboard and his checklists and everything. So I mean, that was over 20 years ago. I was thinking that there would be a movement away from that paper, so that's a real surprise for me to see that we have gone that route. And then a moment ago, you talked about commissioning and how maybe paper is being put to the side now for commissioning. So I thought maybe this is a good transition. We can start talking a little bit about transitioning.
So
do you mean start talking about commissioning or transitioning?
Transitioning to commissioning?
So I think this would be a really good time to start talking about commissioning. Yes. This is staying in. We're not editing that out.
That's fine.
Perfect. So depending on how the contract is set up, depends on the level of commissioning that you do as a contractor. Typically speaking, on larger projects, a separate commissioning contractor is brought in, and their job is to fire it up. But how far do you as an electrical contractor go? On the project I'm on right now, we don't turn on the power, right? We leave it at mechanical completion, and we let the commissioning group handle everything, and then they come back to us and say, nope, there's a problem here, there's a problem there. One of the biggest things that you'll find within pre-commissioning is the repetition in a lot of cases when your commissioning group comes in. And this is where, depending on contract setups, it can be better or worse, or again, cold eyes. Commissioning group's first task in a lot of respects is to repeat the contractor quality control for quite a few things. Like when you're looking at transformers, they'll retest a transformer just to make sure it's good. They'll do some cable retests. They will make sure that the cables are actually going where they're supposed to go before they put power on them, just in case it got through the first two gates. Sometimes, on the other hand, your contractor will also do their own commissioning. You can skip the step of the repetitiveness when you do that, because I know my first job doing quality control, funny enough, for that picture behind you was taken. I did both the quality control and the commissioning on that project, and it was a camp project, so it was pretty basic. But my group went in and we had done all the QC, so we knew that the installation was good, and then we could move just straight to flipping breakers and testing and trying. So your commissioning and your pre-com, again, you'll go through and do basic voltage checks, right? You'll throw the breaker sometimes. Again, make sure your motors are working right. Do you have 600 volts where you expected? Do you have 120 volts where you expected? 24, right? Are you popping fuses everywhere? What's the problem, right? Then it'll either be that part will either be handled by that separate group, or from there it'll be handed off to that separate group, and then they go through full power commissioning, where they're starting to truly test the full system, right? Like how is that transformer? Do we see like our current going through as we would expect? What is that motor doing? So as compared to, hey, does it rotate clockwise or counterclockwise? Can it run for 3 hours and make sure that the heating is not a problem? Are we overheating the motor? And that's uncoupled. Then depending on what you are connected to, is your coupled run working the right way? Is it greased? Is it operating as expected? And I can tell you right now, one of the most boring things you can ever do is stand there and watch an apron feeder run for 3 hours with a little clock beside you. Oh, 15 minutes, walk around with a heat gun. Click, 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 click. But that's the job.
Yeah, I've been lucky enough to do that with generators during load tests after I don't know how many hours, and doing exactly what you said. It's funny how you don't forget some of those things. So we're doing commissioning. So obviously we're talking about electricians here. Explain to me, during commissioning, is the verification of the fire alarm system done by the contractor, then the commissioning contractor, and then also by like the engineer?
That depends who's installing it.
Okay.
Right. Typically, a fire alarm system is actually, that's an outlier, right? And it's a very interesting one that you bring up. There's only so many companies out there, Vipon, Troy, whomever, that they're certified to test fire alarm systems, right? So you would, as an installing electrician, you would go through, you would build your fire alarm system, install it, you do your point-to-point tests, you do meggers if necessary, not all the time, stuff like that. And then you would bring in your third-party test group as the installing contractor. Normally that lies within the contractor scope of work. You would call in the quality assurance people and say, hey, come watch this. And then your Vipond or whomever would have their tech on site, and they would walk through the entire verification progress and system, and that would be stamped and signed by an engineer from that company.
Yeah, it's interesting because like some of the processes that you're talking about would have to be proven and verified. I mean, obviously this is in the commissioning, so you're going to have to watch that product be transformed over a given period of time, and maybe like at a certain crescendo is the word I'm using, I don't know why, but the fire alarm system might have to activate because of X, Y, or Z. So So
Mhm.
yeah, it sounds like a lot of processes, but ultimately, at the end of the day, we're trying to verify that the customer has paid for what they had designed. I'm going to say that again. Ultimately, right, the goal is to make sure that the customer receives what they paid for.
Absolutely. And as you start working through your commissioning, especially, you'll find that your client is there and they'll be there with you a lot of times just to witness your commissioning group in action to say, yeah, like this is working properly.
Can you give us a real world example of what these commissioning stages might look like on a project? Understandably, it's going to be different for every project, but just walk me through a project, real world example.
Yeah, for sure. So was in a mining project in Saskatchewan doing potash. And one of the systems that we were trying to fire up was the automatic ore unloading. And we had to get it from underground to surface. And then from there, it was going out across a 13-kilometer long conveyor to a completely different site to get processed. And I was like brand new at commissioning at that level anyway. So it started off with us making sure that the ore conveyance, it's called the skip, was actually being seen because it was as it moved from underground to surface, it would hit a certain level and it would trigger some magnetic switches. And that would do a slow down sequence, let it know it was approaching, we call it the pocket, and it was ready for offload. So to start with, I'm out over top of this giant hole. And
Okay,
at the
sorry, one
bottom of
sec. Are you with the contractor at this point, or you're with the third party doing QA? Or I guess
actually, I
you're
was
with the
doing,
contractor.
yeah, I was with, no, at that point, I was with a company called Hatch, which was client side.
Okay.
And I was acting as doing
Okay.
commissioning for them.
So you're not the contractor that did the install, but you are doing the commissioning.
That's correct.
Okay. Awesome.
So we're out there. And so basically, in order to get down, they've got this big bored hole. And this bored hole is about a kilometer plus deep, right down to the ground, and well, into the ground. And I'm out on an I beam about yay wide, right? It's probably about an inch on either side of my foot. It's wet and all harnessed up and all the rest. And I got this magnet in my hand. And they're like, okay, we'll test the magnetic switch. We need to see if it works. So I'm sitting there and they're like, again, I'm absolutely crapping myself, right? Because, big giant hole. And I'm trying to get this thing to activate. They're like, no, 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 no. You can't just put the magnet in front of the switch. What do you mean you can't just put the magnet in front of the switch? Well, you have to pretend that you're the skip and the skip rises. So now I'm out on this skinny little I-beam, 1 foot in front of the other, inch on either side, soaking wet. And I have to kneel with this 5-pound magnet in my hand and pretend and pass by. So after an hour of this and the switches aren't working, we came to a realization we needed new switches. So that was the next thing I had to do was swap the switches out. And God love the shaft guys that were there. The worst part about it was, of course, one of these guys that was out there as well as part of the commissioning team. It's like, hey, can you see the bottom? Yeah, I can. Yeah, thanks. So that was one of the first things we did is we were doing the conveyance testing, right? And just making sure that everything goes. Then head underground. And this is over the course of a couple of months. And there were these belts that would feed in and they would feed in ore. So you started off with what was called a feeder breaker, and you had to make sure that the feeder breaker itself was working. Is it responding back to your PLC? Are you getting signals back and forth? Are we getting exactly what we expect? Is it running at the right speed? Can you control it from both a local setup or from your plant PLC up on the surface? And then making sure that your belt is working. Is the alignment switch is working? Does the belt run as we expect? And then, okay, great. Is it set up properly? Is it dumping? Is your ore dumping across from one belt to the next? So you go through all these stages and then you get to what's known as the loading pocket. And the loading pocket itself is a combination of air-driven solenoids to move a table back. So you're going from one skip to the other. You've got load cells in there. And again, you're separately testing all of these things to make sure that each individual component is working, right? So depending on where you are, That can be called dry testing. Sometimes you move into what's known as a wet test. As you start putting the systems together, and okay, great, it can handle the ore, and we can actually process, a couple of tons. I can't remember if it was tons a minute or what it was. It was tons a minute, because those things would fill up with 60 tons every minute and a half, and then up they'd go.
Holy moly.
And oh yeah, it was quite a bit. And then you're checking for things like your load cells, your weights along the whole system. And then finally, you get into full controlled automatic testing. So you'd start with a manual, and you'd run every belt manually, and you'd make sure that you'd run the table that went from one pocket to the next manually, and then manually fill it. Okay, great, we've got 60 tons, up it goes, right? And then you'd send that all, and you make sure that all your signals and feedback are coming through. And then you cross your fingers and you pull off a YOLO, and you make sure that it works on its own. And you're always standing there. And I remember there were 10 of us standing around at all these different places. Oh, did the door open? Yeah, the door opened. Okay, great. Oh, it's dumping in. Oh, crap, close the door. It missed. Right. And that's a real thing. You end up with like 30 tons down below the actual pocket level. And then you get up to the top, and you go through this whole deal, and this thing's working all automatically. And I mean, we tested that out for days. I mean, just standing in front of this bloating pocket, making sure that your table was moving back and forth, and the doors were opening, and the timing on them was still good now that you've got product in there. And you get the skip up to where it's going to offload, and then all of a sudden it gets hung up because they open the door on the bottom and none of the product came out.
Oh, wow.
Right? Because it was wet and it all compacted. But again, I mean, like the first time we did it, we did it with 10 tons, and it was all very controlled. And then after we got our first ore and everyone was, oh, that's fantastic, we'll go home for Christmas, we actually started truly commissioning the unit. And that took us about a month and a bit to run it through its paces, through slow load ups. Okay, great, we're at 15 tons, pushed to 25. Okay, it's still working good. Up we go. And then that was it, right? And it was a culmination of months of multiple different systems going together, and it was pretty cool.
So that material, once you got it out of the ground, then you'd have to commission the conveyor that you said traveled 13 kilometers.
Yep.
Wow, that
Now,
is insane.
Are we talking a sheet of paper for each one of these inputs and outputs to this PLC, like for commissioning?
Yeah,
We're talking a pretty substantial stack of paper at the end of this, with you're getting pretty good at your signature by the end of it.
Oh yeah, that's why you get a stamp. That, or you get a little knob like pushed right into your finger after doing that for a month and a half, just sitting there signing every day. Stamps are good for that.
And what's your favorite brand of pen? I'm sure you've chosen by now.
Oh yeah. I'm really loving the Sharpie. You can actually get the Sharpie ballpoint pens. Yes, the S gels.
Yeah. Huge fan. Yeah.
I actually bring my own S gels to sites because everybody's cheap. Everybody's cheap, right? So, and make sure it's blue. That's the other big one. Make sure it's blue.
So, repetitive nature of QA, QC commissioning. I mean, I'm drawing another parallel in my mind. We said safety before, but to something like estimating, right? Where you come from an electrical background, and it's a pathway that you can take to, if you so want, get off the tools, move into something maybe a little bit different paced. What character traits, what soft skills are you looking for in people who are moving into or want to move into QA, QC and commissioning?
So for QC, first thing you have to be is you got to be good at your installations, and be willing to listen. That's probably the two biggest ones right there. When you come into QC first, your job is to pull everyone's work apart, right? Like you have to be good at going into stuff, quickly removing, say, a panel cover, going through and checking it out, right? You got to be diligent. That's the big thing. There's no shortcuts. Your product is only as good as the person who's doing the first evaluation, right? So people will work for years as QC techs, and they're more than happy for that, right? Like it's a good job. Moving up, after that into a QC supervisor type of role, or a manager's type of role. Knowing how to manipulate programs like Adobe or Bluebeam is a big one. Obviously, having foreman experience is another one. You got to run that crew, right? So the ability to have your guys work with you, plus, and also a thorough understanding of code, of the ability to go through and do your specs and understand how that works. Enough time to have worked with your systems at your company to understand what is expected, and it's not for everybody. Mm-hmm. Right? Moving into that, it's like any manager's type of role, right? You know, you still have to work with people, but then you also have to work with the client, and the client can be demanding. Same as any type of job. So now go one step further. The most hated guy in the company is probably the QC guy. One of the most hated people on the site is the QA guy, because now he's telling you that, or she, that your team didn't do it right. And in fact, you reviewed the paperwork and look at the mess you just gave me. What the hell is wrong with you? Can you not read this document and get through there? So the ability to have a little bit of water off a duck's back is probably huge. If you're the type of person that is aggressive and argumentative, don't go into QA. Don't go into that QC type role. You might do well at a QA role because you're willing to stand your ground. But client relations, especially on the quality side, is huge. Those are your gatekeepers, and having your client QA be willing to work with you so that they can help guide you, train you, to get what they want, so that your company can obviously and ultimately get paid. Right? That's the biggest soft skill, knowing the computer side, being good at creating drawings and all of that. That's one thing, right? You can get people to do that, right? To do red lines, to do markups, to do field evaluation of the unit. But knowing how to manage paperwork, and more importantly, manage the client is going to be big, because if that client's willing to work with you, they'll go to the wall for you. Right? Most of the guys on the QA side are really good in that respect. They will go to the wall, because ultimately, as the EPCM, we need that paperwork, and we need it properly so that we can hand it over to commissioning and get paid. Right? It's that whole step down. Right? So that's the interaction between your field quality lead and your QA person is probably the biggest key to that.
And what's an EPCM?
Engineering, procurement, construction management. That's your client representative, general contractor is probably another good way for it.
Perfect.
Attention to detail, critical for these roles that we're talking about today.
Absolutely.
So huge. I don't necessarily have to have the skill to pull the tech cable, to manufacture the cable tray, right? Those are skills that I don't need, but I need to have attention to detail.
Yes, that's huge. That said, the person that's in there doing QC should have the ability to go out there and outwork the average electrician. Right? They need to be not only a solid electrician and good at their job, they need to be better than others. The last thing you want and or need is to have a person that was really good at detail and being able to look at someone's installation and be able to point out that everything is wrong with it, but can't fix it themselves. That's because you just don't get respect for that, right? Being a good tradesman, probably above all else, is probably the first step and key. And that's normally where you pick your guys from. It's like, that guy's a solid installer, right? Let's bring him into quality control and see how he does. On top of the fact that that they know how to use a computer or have that attention to detail to do that. But normally someone with that eye for detail is usually a really good installer as well.
Having said all that, Andrew, what advice would you give to someone that was interested in getting into this side of the industry? What would be their first step? Don't. Job security for you.
Job security for me. No, if you're interested in it, approach the quality guy, right? Approach your quality person on site with your contractor and say, hey, look, I would really like to get a shot doing quality. This is why I think I'd be good at it. It's like anything. If you want to get off cable tray and you want to work on panels, you go talk to your foreman or your GF and you're like, hey, I've done enough cable tray for the last 2 years. I'd like to start cutting in panels, please. And as spots open, they open. But being vocal about it to the quality control people, paying attention to internal postings, keeping your ear to the ground, and really talking to people, saying this is something I'd like to do. Get noticed, right, in that way. And yeah, it's a big one.
Yeah. So work ethic, I'm going to go back and say you do need some attention to detail, but you definitely do need to be able to walk the walk and talk the talk.
Yep.
And then of course have the soft skills to be able to go and talk to someone on your site and show them that you're interested. And then, like many areas of our industry, right, then you have to ask them again and again and again, right? Be diligent in your attempts to get yourself known, I guess. Yeah.
Oh yeah, no, be persistent. That is probably one of the biggest things there, is definitely it's being persistent.
Andrew, I mean, thanks for spending some time with us. I learned a lot. I learned a couple new acronyms as well along the way. Really appreciate you spending the day with us.
Yeah, you bet. Thank you guys. Really appreciate being here. I know we've been trying to hook this one up for a while, so it was good to make it happen.
Yeah, I mean, we're all about kind of just showing different options within the trade for people who maybe are a journeyman or an apprentice, or where can this take me, right? So it's cool to hear a new side of it that I personally don't have much experience with. So,
all right, well, thanks a lot for joining us today, Andrew. Work safe, and thanks for all the information.
You bet, guys. Thank you very much.
Well, that was very interesting. Happy to have Andrew on the show today, and I personally learned a lot about QA and QC. I mean, especially the difference, since I really didn't know. Jason?
Yeah, we've been hearing QA, QC, and commissioning for years. It's neat to hear that there's another chapter of the trade that people can get into.
You bet. I mean, on that note, we've got lots more episodes coming up for the rest of the year with a focus on that, right? We think electrical's the best trade there is, and it can open up so many doors and lots of opportunity. So stick around, keep listening to the show, follow us wherever you listen to podcasts, and keep in touch. The best way to support the show is to leave a review on Apple or Spotify, wherever you listen to your podcasts, and share it with a friend. Take care out there, everyone.